All right, so the last intermolecular force that I want to talk about is the hydrogen bond. All right, we talked about dipole dipoles. We talked about London dispersions. The last one, the hydrogen bond. This one is the strongest. All right, so remember, dipole forces. There needs to be polar compounds. London dispersion forces. It exhibits everywhere. Everything exhibits those London dispersion forces. Hydrogen bonds. These are the strongest. All right, so with each one of those cases, I've given you the number one key piece of information for those intermolecular forces. Hydrogen bonds are the strongest out of the three. All right, and I'm going to read the definition really quick, and we'll explain it. A hydrogen bond is defined as an attractive interaction between a hydrogen atom bonded to a very electronegative atom, oxygen, nitrogen, or fluorine, and an unshared electron pair to another electronegative atom. All right. So the big thing is, Alexa, go to sleep. So the big thing you have to keep in mind, there has to be a hydrogen, and there has to be at least one of these atoms, an oxygen, nitrogen, or fluorine. If there is not one of these oxygen, nitrogen, or fluorines, there is not a hydrogen bond. All right. So if I ask, consider this compound, consider this molecule, is there a hydrogen bond? Obviously, look for the hydrogen bond, look for the hydrogen atom, and secondly, look for one of these atoms. All right, I think of it as NOF, nitrogen, oxygen, and fluorine. If I don't have any atom from NOF, then I'm not having a hydrogen bond. All right, let's talk about it now. So in this case, we have two water molecules. All right, this H2O here, this H2O here, and we know that water is polar. It's a polar compound because it has two polar bonds and they're facilitated towards the oxygen. Therefore, the oxygen is partial negative and the two hydrogens, that end is partial positive. We learned about that in my last video. All right. This is the same case. We have partial positives and a partial negative. All right. All right. Now, the next question is, well, does it have a hydrogen bond? The first thing you do, again, is look for those hydrogens. We have a hydrogen. Awesome. So, we're almost there. The second question, do we have an oxygen, nitrogen, or fluorine? We do. We have two oxygens. So now we're starting to kick. All right, so now let's look at the example. It says that it's an attraction between a hydrogen atom bonded to a very electronegative atom. So this hydrogen atom is bound to a very electronegative atom, an oxygen. All right, so that's the first part. Hydrogen is bound to oxygen. And then it's bound to an unshared electron pair on another electronegative atom. This is the other electronegative atom, the oxygen. All right, and this hydrogen is bound to the unpaired shared electrons of that other electronegative atom. All right, this right here is a covalent bond. That is not a hydrogen bond. Remember, hydrogen bonds are intermolecular forces. They exhibit between two compounds. This right here is not a hydrogen bond. Right here, the dotted line is a hydrogen bond. The hydrogen binding to that oxygen from a different compound is a hydrogen bond. Let's look at the other example. We have our hydrogen, awesome, and it's bound to a very electronegative atom, nitrogen in this case, it's bound to a nitrogen. This is a covalent bond. All right, the hydrogen bound to this nitrogen is a covalent bond. All right, with that being said, we have a partial positive, and it's going to be attracted to those unshared electron pairs from another electronegative atom. This hydrogen is bound to those electrons of this electronegative atom. This is a hydrogen bond. All right, that dotted line. Hydrogen bonds are intermolecular, meaning that it binds to other atoms. All right. Hydrogen bonds arise because OH, NH, and FH bonds are highly polar with a partial positive charge on the hydrogen. All right, so we've talked about intermolecular forces such as dipole forces, London dispersion forces, and hydrogen bond. I'll catch you guys later. Peace. My little man's crying. Bye.